In this video, we're going to talk about a physical quantity that we call heat. Heat is a type of energy exchange between objects of two different temperatures. Heat is always transferred from a warmer object to a colder one. And this is until the temperatures of the two objects are equal. Hence, heat is a type of energy that manifests itself as the transfer of energy between objects or even parts of an object, due to the difference in temperature. Such energy transfer can cause a change in the state of an object, for example, by changing its state. In the picture we can see two objects, one warmer and one colder. Heat is then the energy that moves from a hotter object to a cooler one, which we have represented by an arrow from a hotter object to a colder one. Heat can be created in a variety of ways, such as burning fuel, sunlight, friction, or passing an electric current through a conductor. In this way, a certain amount of energy is generated or entered into the object, which is then transferred to the cooler objects around it. Heat is a type of energy and is therefore a physical quantity. Heat is indicated by the capital letter Q. As with other types of energy, the basic unit is again the joule. And we would be able to determine the amount of heat that has moved from one object to another. We need to know one more physical quantity. We call it specific heat capacity. This is because every object is capable of storing energy. The conservation of thermal energy then consists of changing the temperature of the object. However, objects made of different substances are able to store heat energy differently well. Some substances can store large amounts of energy without changing their temperature much, while others can store a much smaller amount of energy. Thus, specific heat capacity is a value that depends on the type of substance. If we were to say what specific heat capacity is, it is the amount of energy required to heat 1 kilogram of a given substance so that its temperature increases by 1 degree Celsius. The specific heat capacity is denoted by the letter C. Its unit is made up of several different units and is very complex. The basic unit is the joule per kilogram per degree Celsius. To better understand what is meant by the specific heat capacity of a substance, let's take a look at an example. Let's imagine that we have 1 kilogram of copper and 1 kilogram of water. Both substances have the same mass, but also the same temperature, namely 20 degrees Celsius. Now let's imagine that we heat both substances. That is, we are supplying both substances with some energy. In order to heat the copper by 1 degree to 21 degrees Celsius, it is necessary to supply the substance with 383 joules. However, we would need to heat the water much longer, as it would take 4,180 joules to heat the water by 1 degree to 21 degrees Celsius. So, we put some heat in both substances. Thus, water as a substance has a greater specific heat capacity because it is able to store a much greater amount of energy than copper, and even more than 10 times. It is true that every kilogram of water is heated by 1 degree Celsius with the delivery of 4,180 joules of heat. And it is equally true that every kilogram of copper is heated by 1 degree Celsius if we add 383 joules to it. If we had 2 kilograms of water, we would need twice as much heat to heat 1 degree as for 1 kilogram. For each kilogram of water, we would have to supply 4,180 joules of heat. Altogether for 2 kilograms, that is 8,360 joules. If, on the other hand, we wanted to heat 1 kilogram of water by 2 degrees Celsius, we would have to supply 4,180 joules of heat for heating for every 1 degree. So again we come to the supply of 8,360 joules of heat. Thus, the heat supply is directly proportional to the change in temperature and the change in mass. It is also important when calculating the heat supplied that each substance has its own specific heat capacity. As we have already discussed, copper has a different specific heat capacity than water. Furthermore, iron has a specific heat capacity of 450 joules per kilogram per degree Celsius. This means that 1 kilogram of iron needs to be supplied with 450 joules of heat to heat it by 1 degree Celsius. Next, we have aluminium in the table, which has a specific heat capacity of 896 joules per kilogram per degree Celsius. Again, this means that 1 kilogram of aluminium, when it is supplied with 896 joules of heat, it will heat up by 1 degree Celsius, You may notice that water has a much higher specific heat capacity compared to the metals listed in the table. This means that it is much more difficult to heat water than these selected metals. Specific heat capacity is a tabular value. This means that it can be found in mathematical and physical tables for various specific substances, or on the internet. Now we come to the formula for calculating the amount of heat supplied. We have said that the amount of heat is directly proportional to the change in temperature and the change in mass. We have also said that the amount of heat depends on the specific heat capacity of the substance. So the formula for calculating heat looks like Q is equal to C times M times the parenthesis of the T2 minus T1 end of the parentheses. We know that C is the specific heat capacity and M is the mass, but the difference between the two temperatures at the end of the formula is very significant. The temperature of that one is the original temperature of the substance. That is, the temperature at the beginning before adding or removing heat. The temperature of the other two is the end temperature. It is the temperature to which the object has heated or cooled after heat has been supplied or removed. The difference in these temperatures, which we have now marked in red, is called the change in temperature, and in some tasks this designation will come in handy. Now let's solve a few heat problems together. In task number 1, we have 2 kilograms of water at a temperature of 20 degrees Celsius. And we have to determine the heat in the jugs that needs to be supplied to heat the water to 21 degrees Celsius. First, let's write down the quantities we know. The specific heat capacity of water is 4,180 joules per kilogram per degree Celsius. Next, we know the mass of M, which is 2 kilograms. The original temperature of the one from which we heat is 20 degrees Celsius. Next, we know the end temperature of the two, which is 21 degrees Celsius. This would list all the physical quantities we need to calculate heat. So the formula for calculating heat is Q is equal to C times M times the parenthesis of the T2 minus T1 the end of the parentheses. Gradually, we substitute for C 4180, for M 2 kilograms, T 120 and T 21 degrees Celsius. This gives us the numeric expression 4180 times 2 times the parenthesis 21 minus the 20 end of the parentheses. Then we calculate the numeric expression. The temperature difference of 21 minus 20 is equal to 1. So we get 4180 times 2 times 1. When all three numbers are multiplied, we get a final value of 8,360 joules. The heat that needs to be given to 2 kilograms of water to heat them from 20 degrees Celsius to 21 degrees Celsius is 8,360 joules. With that, we have completed task number 1. In task number 2, we have 2 kilograms of water at a temperature of 20 degrees Celsius. And we have to determine the heat in the jugs that needs to be supplied to heat the water to 23 degrees Celsius. First, let's write down the physical quantities we have at our disposal. The specific heat capacity of water is 4,180 joules per kilogram per degree Celsius. Next, we know the mass of M, which is 2 kilograms. The original temperature of the one from which we heat is 20 degrees Celsius. We also know the terminal temperature of the two, which is now 23 degrees Celsius. This would list all the physical quantities we need to calculate heat. Again, we're going to write a formula for calculating heat, which is Q is equal to C times M times the parenthesis of the 2 minus the end of the parentheses. Gradually, we substitute for C 4180, for M 2 kilograms, for 120 and for the 23 degrees Celsius. This gives us the numeric expression 4,180 times 2 times the parenthesis 23 minus the 20 end of the parentheses. Then we calculate the numeric expression. The temperature difference of 23 minus 20 is equal to 3, so we get 4,180 times 2 times 3. After multiplying all three numbers, we get the resulting value of 25,080 joules. The heat that needs to be added to 2 kilograms of water to heat them from 20 degrees Celsius to 23 degrees Celsius is 25,080 joules. With that, we have completed task number 2. In task 3, we have 6 kilograms of water at a temperature of 73 degrees Celsius, and we have to determine the heat in kilojoules that the water gives up to its surroundings to cool down to 23 degrees Celsius. First, let's write down the physical quantities we have at our disposal. The specific heat capacity of water C is 4,180 joules per kilogram per degree Celsius. Next, we know the mass m, which is 6 kilograms. The original temperature of the one from which we cool down is 73 degrees Celsius. The final temperature of the two, to which we want to cool down, is 23 degrees Celsius. This lists all the physical quantities we need to calculate heat. Again, we're going to write a formula for calculating heat, which is Q is equal to C times M times the parenthesis of the 2 minus the end of the parentheses. Successively substitute the number 4180 for C, the number 6 for M, and the number 73 for 1 and the number 23 for the 2. This gives us the numeric expression, 4,180 times 6 times the parenthesis 23 minus the 73 end of the parentheses. First, let's start subtracting the numbers in parentheses. 23 minus 73 is minus 50. Then we get 4,180 times 6 times minus 50, which gives us a result of minus 1,254,000 joules. If we want to convert joules to kilojoules, we're going to divide the heat minus 1,254,000 by 1,000, because 1 kilojoules is equal to 1,000 joules. So we get minus 1254 kilos of joules. A negative number only tells us that the heat has been given away by the object, not taken in. Thus, the heat that water gives up to its surroundings to cool it from 73 degrees Celsius to 23 degrees Celsius is 1,254 kilojoules. With that, we have completed task number 3. In the fourth task, we have a copper rod weighing 250 grams that has been heated by 600 degrees Celsius. Determine the amount of heat that the rod has received from the environment. The specific heat capacity of copper is 383 joules per kilogram per degree Celsius. Next, we know the mass m, which is 250 grams. However, we need to convert this mass into kilograms, which are the basic units. Thus, 250 grams is 0.25 kilograms after conversion. The last value we know is that the copper has warmed by 600 degrees Celsius. We don't know the original temperature of the copper, but it means that if the temperature of the copper was originally 50 degrees Celsius, the final temperature would be 650 degrees Celsius. If the temperature was originally 20 degrees Celsius, the final temperature would be 620 degrees Celsius. The important thing is that the temperature difference is 600 degrees Celsius. So we know that the 2 minus 1 is 600 degrees Celsius. This lists all the physical quantities we need to calculate heat. Again, we're going to write a formula for calculating heat, which is Q is equal to C times M times the parenthesis of the 2 minus the end of the parentheses. Gradually, we substitute for C 383 for M 0.25 kilograms and for the temperature difference, i.e. for the whole bracket, the value of 600. This gives us the numeric expression 383 times 0.25 times 600. Then we calculate the numeric expression. After multiplying all three numbers, we get the resulting value of 57,450 joules. So the heat that the iron rod received is 57,450 joules. With that, we have completed task number 4. Finally, let's recall what we said about heat in this video. Heat is a type of energy that moves from a hotter object to a cooler one. The unit in which heat is calculated is the joule. You should also know that each substance is capable of absorbing heat differently. The ability of a substance to absorb heat is called specific heat capacity. It is the numerical value of a substance given in tables. That's it for this video. If you like the video, then don't forget to like or subscribe.